So this page is visible to everybody, right?
Yes, sir.
Okay, so I think you can note down the URL, or maybe I will just also type in the URL in our this general post box of MS Teams. Yes, I have just posted it there also. So so this page will have any kind of announcement that we do, but since we are having MS Teams, so everything will also be there. So myself and Professor Pralay from Computer Science will be taking the course. I will be focusing on GPU architectures, a bit of that, and primarily CUDA programming and efficient. The key objective, since this is a CS course, so the key objective is to teach performance-aware efficient CUDA programming, which will require you to know a bit of details about GPUs, because unless you know how a GPU function, it's very difficult to write a program which is efficient, right? And as we know that CUDA is one of the popular accelerated programming languages specific to GPU accelerators from NVIDIA. So that's quite popular nowadays due to several reasons we will discuss. And the other person, Professor Pralay, he will be teaching two different paradigms of HPC programming. One is OpenMP. So OpenMP basically provides you with constructs, so that is basically like a wrapper over standard C++, so that you can have multi-threaded programs running on multi-core architectures. As we are all aware that even our modern, I mean, if you have a laptop, there is a big chance it's having an i5 or i7 CPU, where you have a quad core or dual core setting, so you have multiple cores. If you write a normal C program and run it in your laptop, typically what happens, it's your compiler will generate a sequential code, and it's up to the processor to figure out smartly whether it can execute multiple instructions in parallel at runtime or not. But if you use something like OpenMP, then you can actually, as a programmer, you can give directives which will tell the system that, well, these are the things which will run in several different threads, and these are the things which will be mapped to parallel cores. And then the program really gets a boost in terms of accelerated execution. And there is another popular distributed programming interface called MPI, or message passing interface, through which you can actually write programs which will be running in clusters with multiple nodes, communicating among each other through messages. So that's the other paradigms which Pralay will touch upon. Okay. Now the thing is, we both are loaded this semester with many courses, because we both also are teaching this programming and data structure course. As you know that the first year semester has fallen into a phase lag, right? And due to that phase lag, we are now having a intersection of two semesters, and unfortunately both of us are taking first year classes as well as two theory courses in this semester. So each of us have three courses to handle. So what we are doing is, in this course, I will be the primary teacher in January and February, and maybe again back sometime in the last 2 weeks of the first 2 weeks of April when you have classes. And Pralay will be teaching in the month of March. So he will be discussing at those points of time the modules on OpenMP and MPI. And for the months of January and February, I will be teaching the following modules. We'll be posting lecture videos in Teams, and we'll be always having a live session for the course in this slot, that is 5 to 6 p.m. of every Thursday. Okay, so this will be our constant slot where we do live session, and we will not have a upper bound on the time, because I don't think anybody has got a class after 6. So we will start at 5, and if there are queries, we will continue for that week. So this is how we will do. So overall, we have made a breakup of weekly modules. So we will start initially with some amount of primer on basic computer architecture. Now, of course, we have a lot of excellent CSE and EC students in our class, I hope, who are already aware of basic computer architecture, but this we have to teach for completeness purposes. So we'll just touch upon how a CPU usually works, and what are the internal details of a CPU, cache, memory, the pipeline, and then we will touch upon how a GPU architecture is kind of organized. So that is the module we will be talking about in the basic computer architecture part. Well, in the next week's lectures, we will be providing with a snippet of the first CUDA program, and in that through that we will introduce you to this wonderful world of GPU programming. Primarily, since we are using CUDA because of its popularity, and CUDA is specific to NVIDIA class of GPUs. So we will try and understand why GPUs have become so important, what are the architectural differences of GPUs and CPUs, and I mean how this kind of accelerated programming is driving the world nowadays in terms of high performance applications, like mostly the AI applications. As we know that all AI applications, both the learning and the inferencing engines, they are all running in CPU GPU systems, and it is not only in AI but several other engineering domains, let's say mechanical, fluid dynamics, and all other domains, let's say gene sequencing. Everywhere people are able to get their simulation accelerated by using this kind of accelerator oriented programming, either a CUDA or OpenCL or some other accelerator oriented SIMD programming. So we will have our hands inside CUDA at a basic level in the first module. Then immediately in the next module, we will get to much more deeper details. So we will be trying to think about, well, in the first module, we learned how to write a CUDA program and how to make it work, which gives us enough knowledge to write a problems to statement in a CUDA style code. But in the third module, we'll try and understand, well, given this CUDA program, how does it really execute inside the GPU? Because this is a parallel program, right? So when you have a parallel program executing inside a hardware, there are a lot of problems that can happen because the hardware has now got a lot of responsibility. It has to advance all these parallel threads in parallel together, and that will throw up a bunch of problems because some of the threads will get stalled, some of the threads will request memory access. So all these issues the architecture has to address. We will learn how these things are managed by GPU hardware, how threads are scheduled, when do threads diverge, when do threads stall, and all these things, right? So that's about the third module. In the fourth module, we will learn a little more about how the memory organization inside a GPU is really, how it really looks like. So that would mean, as you can understand, that compute cannot work without any kind of IO with a memory. Well, you write a program that works, but it requires data, right? So how your architecture is managing the data placement, how it brings the data from the RAM to the cache and to the CPU registers is a very important thing. Now the memory hierarchy of GPUs are significantly different from CPUs, and if you are writing a program which if you have designed a GPU which is very fast, but its memory hierarchy is not proper, then it will not work. If you write a program which is very efficient algorithmically, but it is not aware of how the GPU memory is organized, again it won't work. So we will try and understand how the memory organization is really there in GPUs, and to exploit that, we will take the very popular example of matrix multiplication, and we'll see how standard matrix multiplications can be optimized using tiling, taking advantage of the GPU memory hierarchy and all that. With this, we'll advance to the next module, where we will pick up another matrix operation called transpose. Now, I hope everybody understands what matrix transpose is, because everybody knows here linear algebra quite well. We'll try to see how a transpose operation can be accelerated in the GPU, and there are very good reasons. Some of you may be wondering, well, what is so great about transpose? Is just taking an ijth element and putting it in the jith position. Yes, that's true, but think about doing it in a billion-sized matrix. It becomes a real issue, and we will really show that why it's a real issue and what kind of critical thinking is really required by a programmer to get good performance for doing transpose. Now you may be questioning, well, why we are focusing on matrix multiplication and transpose? Think of any ML workload. Most of the elementary operations you will be doing inside are matrix additions, or better to say tensor additions, multiplications, and transposes, right? So as long as these basic operations are not being efficiently done, your program, your PyTorch, your some other tool, your TensorFlow, they are not going to be very efficient. So that's why these are very, very fundamentally important. And if you look at modern CS systems companies, let's say this Google and others, well, they are great software companies, but they are also great systems companies. That means they maintain large scale systems. They have got significant amount of investment in HPC systems. They have a lot of interest in GPUs and HPC programming, which is performance aware, right? So these kind of skill sets are extremely valued by these CS companies, which of course you all know better than me. Well, now coming to the sixth module, we will pick up another similar programming problem, reduction. Well, reduction is nothing but you are given a few numbers, how you can add them very efficiently. Again, you may be wondering what's so great about it. Well, it matters if you can add, let's say, a million values in parallel using some optimized code. So that is why we are taking these simple operations, and we will be showing how after 5 or 7 optimizations, a naive vanilla CUDA kernel for doing a reduction can be optimized by those different phases, and we get a 10x, 20x, 30x speed up. So that really matters. So that's what we'll cover. And after that, we'll have the seventh module where we will be talking about some more optimizations. Now, these optimizations are a bit critical. Is basically like suppose you are given multiple CUDA workloads. Let's say you have a convolution kernel and you also have some other filtering kernel to work with. Now, well, I can execute the convolution kernel and later on I can execute the filtering kernel, some other filtering kernel, what I mean. But let's say I have a good GPU. So there are enough number of processing cores there to support them together. How do I co-execute them together in the most efficient manner? For that, to appropriately model this kind of interaction of multiple kernels and execute them together in an optimized way, there exists lot of optimization techniques, and these are known as kernel fusion. So to say, suppose you are given kernels K1 and K2, how you can take these two pieces of code, mix them up and write a single code so that once that executes, you get both the kernel functionalities done, but in a much more efficient manner, making good use of the available programming hardware. Now the second one is coarsening, which is another optimization which is used by CUDA kernels, or for that matter any other GPU kernel, for making better use of the available hardware. In the last module, we will be talking about building NN-based inferencing engines and NN trainings and how they can be optimized using this kind of facilities that a GPU provide. So essentially what we will be doing is we will be bringing on the idea of computational graphs, and we will be figuring out how neural network training and inferencing can be mapped to a computational graph problem where all you are doing is matrix multiplication, addition, and transposes over a graph. That means there are several dependencies to work out with. So these are the different topics that we will be covering. For this, we will be having a set of videos which we will release every week. Let's say after today's class, we will be posting a few video lectures which you can go through minutely. And in the next week, again during Thursday, we will have a doubt clearance live session where we will be trying to resolve all those queries. So this is how the course will progress from our side. Also, every week or maybe once in 2 weeks, the teaching assistants will be conducting a tutorial session. So what will happen in the tutorial session is, well, they will post some problems. So earlier what we used to do is we'll have tutorials where we gave quite significant problems and asked the students to solve them out, and we will be grading the tutorials and all that. But this time, since we are having more number of tests for the continuous evaluation policy, so we are not going to grade the tutorials. So the tutorial sessions will largely involve, some problem demonstrations by the TS. So they will actually demonstrate some CUDA programming examples, and the examples will be tuned in such a way that they bring out certain specific aspects of CUDA programming related to performance, memory usage, and all that. Okay. So that's how the tutorials will happen. Tutorials will be taken in one of our teaching slots, and that will be communicated beforehand through the MS Teams by myself or the teaching assistants. So that's how we will do it. And we have also drawn up a evaluation schedule for the course, which is like this. So in this period of the semester, we will be having 4 exams. There will be 2 short tests. Short test means, let's say the duration is 30 to 40 minutes. So, and the syllabus of the short test will be based on this module. So let's say we have one short test in in the last week of January, and this in this short test, what we'll be doing is basically covering the first 2 modules. So this is like a introductory test where we'll be covering the just basic CUDA programs with some knowledge of basic comp. Primarily we will focus on the basic CUDA programming skills that we'll teach in the first 2 weeks. In the second short test, we will be having this will be more intensive because we will be the syllabus will be involving architecture aware CUDA programming and also memory aware CUDA programming. In the then we will have the long test. So this will be a significantly big test. Let's say 1 hour 30 minutes, something like that. And here we will be basically covering all the topics. So this will happen in the first week of March, and this will be covering the entire GPU programming syllabus that we will be covering on course of time. And as you can see, all the tests we are scheduling them on our Monday teaching slot 5 to 6 p.m. Well, for the long test we will need more time, so that timing is not given. We will decide the time, but it will be on first of March. So that's our idea of evaluation for the CPU GPU part. In the month of March, you will be taught the OpenMP and MPI modules, and for that there will be another long test taken by the corresponding instructor. The date he will be announcing. So that will be our way of evaluation. And there is some another component, which is the term project component. Now the term project component will also be from our CUDA programming part, not from the OpenMP MPI part. So what we'll do is we will form 8 teams out of the class, and we'll have a set of problems which we will identify, based on some recent ideas, some recent innovations on CUDA programming and architecture aware programming. And those problem statements will be given to these different teams. So they have to provide software solutions, and they will be demonstrating their solutions along with a presentation in the timelines that are provided. So these problems will be handing them over in another week, or let's say another 10 days time, so that you have the entire time to figure out through the course. But this is the timeline in which you have to actually do the presentations for the term project. So in the first week of April, the first 4 teams will be presenting their project works, and in the second week of April, the last 4 teams, the 5th, 6th, 7th, and 8th teams will be presenting their project works. So that's how we'll be organizing it. And this is what is our marking scheme. So from the 2 small tests or the short tests, we will be deriving 10 marks each. So that's 10 plus 10, 20. From the 2 big tests, we will be deriving 30 marks each. So you have 60 marks. So 60 and 20 is 80. And from the term project, so we'll have 20 marks. So as you can see, the term project is a serious thing. So take the term project, very seriously. So in that way, this is what we will be doing. But you should be following our video lectures very minutely, and all the material we are providing, you should be following them very minutely, so that you can excel in all the tests that we have. Now, don't think that these tests, the short test and the long test, will be just programming tests. That is not the case. See, this is a theory course. This is not a lab course, right? We are going to teach you programming context, but it's actually architecture aware programming. So there will be several theoretical questions which will be testing your knowledge of CUDA and programming internals or architecture aware programming, right? So well, we can discuss some problem statements like that when we do the tutorials. Those things we'll be doing, or we'll have some weekly assignments on that. And apart from that, as you can see, these are the reference books that we will be providing you. you can actually get them very easily. For example, this CUDA programming guide is a very popular source. I mean, it's actually available in NVIDIA website, and this has got more or less everything, the syntax of different CUDA statements and all that. So you can just have a look into this. And there are several good books. For example, this is the book on OpenMP, which the other teacher will possibly be following. And on CUDA, I think this is the most well-known book that is available. It's a very easy reading book. So programming massively parallel processors. So that's the book name, and it has got some good programming examples also. And for basic Coa, well, I think our slides will suffice. But if you want to go through a book, this is the go-to book for us by Hennessy and Patterson, Computer Architecture: A Quantitative Approach. So you can look into the first two chapters of this book. But anyway, we will also be teaching you all those things. So in this first meeting, we wanted to introduce the course to you. Now, well, we are open for discussion, so you can shoot any question which we'll try and answer.
Sir, is the term project team wise or?
Term project is team wise. Yes.
So like it's shown that there will be only 8 teams, and there are
Right.
so won't there be too much members per team?
You don't worry about these things. The projects will be given like that, where too many members will be required.
Okay.
And team formation, problem formulation, problem mapping with team, these things we will take care of. So we'll not ask for suggestions and those things, because we will see what is the background of the student. Accordingly, we'll try to put them together, and we'll try to give a problem statement which is suiting their background, stuff like that. So we don't leave it to the students, and we avoid chaos in this way. We have been doing that quite successfully for the past few years, so there has been no problem.
Okay, sir.
So initially, when we used to give term projects, people will come and say that, sir, I am from this department. Why have you put him with another person? Or I want to be in a group with my friends and all that. But all those requests were summarily rejected, because we, we, we are the only person who are having a global view here. We can see who are the students coming, what are their backgrounds, what kind of problems can they say. For example, there is somebody coming from a mechanical and aerospace people. We like to club them together and give something related to, let's say, fluid dynamic simulation. We did this kind of stuff, just to give you an example. So this is how we formed groups, and we gave significant programming assignments. Well, I think one very important query from your side would be, well, I mean, where do you code? Not everybody is having a laptop with a GPU, right? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
So where do you write the programs?
Google Colab.
Yes. So everybody knows Google Colab?
Yes.
Yeah.
Yes, sir.
Yes, sir.
Okay, so what will happen is we will, in our first tutorial session, I think we'll be giving a demonstration on that, and we'll be the primary, the primary the go-to solution for us in this case would be Google Colab. So
So, but
anybody who is not,
OpenMPA is a C++ proper, no, so
yeah,
so Colab.
I'm not talking about that part. I'm only talking about the CUDA programming part.
Okay.
So for that, we'll be using Google Colab, the CUDA programming part. So if you have got a Colab setup already with you, it's nice. If you are not, familiar with Colab, get yourself familiar, because that would be the platform. It's a very intuitive, easy to use platform. So get familiar with that. Okay. Any other question? Ashutosh Singh, are you there?
Yes, sir.
Yes. Any questions from you?
Hello, sir.
Yes.
Yes, sir. What did you say?
Okay, I just asked if you have any questions. As simple as.
No, sir. Nothing as of now.
Okay. Yes. Somebody else wanted to.
So, like, are there any other prerequisites apart from programming in C language?
Not now, but as I said, we will have some initial classes on CompArc, computer architecture. So if you have not done a course on that, be attentive in those classes, and we will be referring certain books and materials. You should go through that. Okay.
Sir, is there any way to run these CUDA programs on AMD GPUs?
I guess not. I think AMD would have some other environment for that because I have never tried actually. But I can just check and get back to you. Just give me a minute. 1 minute.
So AMD has got ROCm. That's their project.
Yeah, they have a separate environment which I know. But I will just check if AMD has got some port for CUDA. I don't think so because still now there aren't any such. Because I mean, okay. Why are you asking this question? You have a system with AMD card?
Yes, sir.
So actually there is an alternative to CUDA called OpenCL, which is supported by most of these vendors, but it's not so popular because it's a bit low level. It's much more powerful, but it's also a bit low level. So for all programmers, CUDA is kind of a go-to. So we are also following CUDA in our course, but these languages are all basically what we call as SIMD based programming languages, data parallel programming languages. The idea is you write a kernel code which will always launch an n number of threads and all of them will execute all the instructions in parallel, something like that. So in different ways, these different languages like CUDA, OpenCL, and there are other languages like DPC++, SYCL. They all follow this pattern of what we call as a host device programming language. We will get into those things, but due to their vendor policy and other things, they often support different platforms. Now, since CUDA is almost universally used, we are going with that right now. But if you learn CUDA or maybe one of the languages, all the others are very similar in semantics. So that will be clear to everybody. So, okay, if we don't have any other question, then we'll end today's live session. And by tomorrow, we will be sending you some introductory videos for the course. You will study them and we'll have a forum for posting questions and we will be discussing them in the next lecture. That's how we'll proceed.
Hello, sir.
Yes.
So, like tomorrow, there will be no live classes. Like we will only see the videos.
Yeah, so that's how we'll go about it. We'll have recorded videos which we'll provide you. And every week we'll have a live session for doubt clearing and a bit of extra teaching on that. That's how we are going to take it this semester. This is the slot which we will be having always a live class on Thursday 5 p.m. Hello.
Yes, sir.
And just one disclaimer, like this may not always be true. Like it's not that every topic will be covered in video. Just to make it sure, like there are some topics on which we will have some extra discussions in the live classes. I mean to say, don't think that the live class will only be for doubt clearance. For certain detailed topics, we'll be use the live classes also for extra teaching. So that will also be there. Okay. Any other query from anybody? Okay, I got something from. Oh, there are a set of questions here. Attendance will apply for our live sessions. See, there is no issue of attendance here. I mean, we are not recording your attendance. So even if you are not in the live session, I don't really care. But I will ask you to be in the live session and come up with nice questions, because otherwise I will start thinking that we are not doing anything meaningful. But it's okay if one day you don't have anything and you drop out from the session, it's okay. This is an online semester, so we are not making too many rules. We are trying to keep things as flexible as possible without losing out on the academic part. That means it should not happen that since we are recording videos and all that, so we miss on teaching concepts. That will not happen. We are just saying, since we are doing some pre-recorded videos, well, we'll use them to augment the teaching. Definitely we'll have these sessions and maybe more sessions if required for doubt clearance, for extra teaching and all that. Okay. So there is another query. 27th to 3rd March is spring break. Is it possible to reschedule the long test? Okay, so there is a spring break that semester. I forgot about it. Okay, that is good thing, because if there is a spring break, then I can also utilize it. So Anirban, we have to shift this date. Please remember, we'll make. Yeah, this is definitely true. We should not have because this is the most critical exam, at least for the CUDA part, right? Because it has got a lot of weightage. So definitely we should have it after the spring break. No problem with that. And also I have a request, like so in Teams we will have a open student discussion channel. So we'll create those channels. There is a general channel, there will be a student discussion channel. So you can post any query there anytime you want, and you can be as critical in your posts as required. I mean, nobody is judging you for being critical of some content or some coverage and all that. So we are quite flexible here. So take it like that, because when we teach this course, I mean, it's at the end of the day, it's a programming course. Which is very much performance aware, a bit different from first year C programming. It requires some advanced concepts of architecture also. So it's kind of a fun thing to do. So we try to keep it an enjoyable experience. So things are very flexible, but it's also very academic. So if any kind of query you have, post there. We will try to understand and figure out and explain what you are trying to, I mean, what is your problem? I mean, with respect to your problem, as much as possible. So we will be doing two things, by the way. We will be providing the video links, which you will be looking into, and also we will be uploading the teaching slides. We are making some teaching slides now in a weekly manner into this in this portal itself. So both will be there, and we will be having these sessions.
Sir, I have just one question.
Yes.
Last year, as far as I know, there were programming assignments that were given, and along with term projects. So what that would have helped is that it would have helped us to ease out on our experience on like hitting the ground running when we are coding the term projects. So even if it's not graded and only for those who are interested in doing those assignments, can you please upload the last year's assignment? If it's
No, we will be giving assignments. Maybe I was not clear. In every tutorial, we will be giving assignments only to you to do, for you to do. Okay. And maybe after a week, we'll be going the solutions and stuff like that. We will be not grading them. That's what we are saying.
okay. Thanks, sir.
Because as you can understand, we also have to take the four exams, right? Because this is a continuous evaluation thing. So we don't want to load people with exams as well as assignments. So programming assignments will always be given, but we will not grading the weekly assignments.
Sure, sir. Thank you.
Mm-hmm. Okay, Sharnavo, third year EC students have lab till 5, which extends to 5:30. Will it be possible to shift the session to Friday rather than keeping it on Thursday? Let me check. So how about Monday? We have a class slot on Monday, Thursday and Friday.
So on Monday we have a lab till 5 again.
Okay, your lab is also from till on Monday.
Yes, sir.
No, but see, this is mostly like a live session, right? Which means it's fine if you join at 5:30 with your, but anyway, then you will miss the other people's discussions. So that's not a good thing. Okay, now somebody is saying some of us have a lab on Friday as well. So see, there is no point in really trying to solve this thing because this is a course slot, right? So ideally your lab should end at 5. It's an online lab, right? See, if you have a lab, you should make it clear to the lab instructor that there is a slot for a course from 5 and you can just leave at 5. It should not be a problem because like the problem is there. If I cannot shift on Friday because some people have Friday lab and all that. So let's solve this by simply sticking to the slot. You make it very clear that we have a course from 5 and the lab slot is up to 5.
Sir, actually, Thursday slots are fine for classes, but on the Monday lab, the course instructor has told us that we'll be expected to submit our reports by that day only. So, so we don't have classes on Monday, but later when we have tests, that might.
I understand. So we continue with Thursday only.
Okay, sir. So the test also will be conducted on Mondays only then.
We can shift the time of the test by 30 minutes if that solves your problem.
Okay, sir. We'll discuss it with our lab instructor once.
Because you can tell that today we have tests, so please. Because anyway, the long test we will take at night because it will be, let's say, more than 1 hour, right? So long test will be at night.
Okay, sir. Thank you.
Sir, on Monday, actually, some of the electrical engineering students have a lab from 6 to 9 p.m. So at night, it might be a problem on Monday if there is a test.
You have a lab from 6 to 9.
Yes, the
what
instructor
happens during the day? During the day, there is no academic work. There are routines and all that.
No, actually, the instructors wanted to conduct all the batches together on one day. So they didn't find a slot, so they made it from 6 to 9 p.m. on Monday.
Okay, but I think 5 to 6 is fine because anyway that will be a 40-minute exam. So if we, I think whoever has lab up to 5, they can speak with their instructors on the exam of day and say that, well, we have an exam, so please end the lab at 5. That's the slot, and we can have the exam 5 to 6 then. For the long test, we will see some other time.
Okay, sir.
Okay, anything else for today? Hello.
Yes, sir.
No, sir.
Yes, sir. No, we don't have any doubts.
Okay, so I hope this will be a good experience, this course. Let's meet again next week. Bye for now. Yeah, we'll be putting in some lecture videos and material in between. Study them well, and we'll be floating around a query form where you can post all your doubts. We'll look to it. We'll come prepared for the next live session then, based on the doubts. Okay. Yeah. Ta-da.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Bye.
Thank you, sir.
Thank you.
Thank you, sir.